Building a robust and scalable payment system with AWS Serverless architecture. This podcast is brought to you by Business Compass, LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: the importance of secure payment processing. In today's digital era, secure payment processing is crucial for businesses of all sizes. With the rise of e-commerce, mobile apps, and online services, the need for robust and scalable payment systems has never been more critical. This podcast will guide you through building a secure and scalable payment processing system using AWS Serverless architecture. We will cover everything from setting up your infrastructure to implementing security measures and ensuring scalability. Working architecture for seamless payment processing. A seamless payment processing architecture leverages AWS serverless services to ensure high availability, scalability, and security. Here's an overview of the architecture components. Client application, mobile or web app for user interactions. API gateway, handles API requests and routes them to appropriate services. AWS Cognito, manages user authentication and authorization. AWS Lambda, processes payments and interacts with other services. DynamoDB, stores transaction details. AWS SNS, sends payment notifications. CloudWatch, logs and monitors payment processing activities. Client app and JSON requirements. The client app interacts with the backend using JSON-based RESTful APIs. Here are some typical JSON requirements for the payment process. Payment request. User, ID, user 123. Amount, 100.00. Currency, USD. Payment, method, credit_card. Card, details. Card CUM, number, 1234. 5678-9876, 5432, expiry, TAT, 1225. CVV, 123. Payment response. Transaction, ID, TXN 123. Status, success. Message, payment processed successfully. Setting up API gateway and Cognito for user authentication. Create an API gateway. Navigate to API Gateway in the AWS console. Create a new REST API. Define resource paths and methods, for example, /payments with the post method. Set up AWS Cognito. Create a new user pool in Cognito. Configure app clients and set authentication settings. Integrate Cognito with API Gateway for user authentication. Configuring API Gateway Authorizer with Cognito. Configure Cognito Authorizer. In API Gateway, select your API and navigate to the Authorizers section. Create a new Cognito Authorizer and link it to your user pool. Attach the authorizer to the API methods that require authentication. Lambda function for payment processing. Create a Lambda function. In the AWS console, navigate to Lambda and create a new function. Write the payment processing logic. Here's a simplified example. Import JSON. Import Boto3. Def lambda _handler event, context. #extract payment details from the request. Payment _details equals JSON.loads event body. #process payment, pseudocode. Transaction _ID equals process _payment _details. #store transaction in DynamoDB. Store _transaction _ID, payment _details. #trigger SNS notification. Notify _user transaction _ID, payment _details. Return. Status, code, 200. Body, JSON.dumps. Transaction to, ID, transaction _ID. Status, success. Message, payment processed successfully. Using DynamoDB for storing transaction details. Create a DynamoDB table. Navigate to DynamoDB in the AWS console. Create a new table with a primary key, for example, transaction ID. Store transactions. Integrate DynamoDB into your Lambda function to store transaction details. DynamoDB equals boto3.resource dynamodtable equals dynamod.d.table transactions. Def store underscore transaction underscore ID, payment underscore details. Table.put underscore item. Item equals transaction t, id, transaction underscore id. Details, payment underscore details. Triggering AWS SNS for payment notification. Set up SNS topic. Navigate to SNS in the AWS console. Create a new topic for payment notifications. Publish notifications. Integrate SNS into your Lambda function to send notifications. Sends equals boto3.client SNS. Def notify underscore user transaction underscore ID, payment underscore details. cns.publish. Topic, Arne-Qualcern, AWS, SNS region account IT topic name. Message equals payment, transaction underscore ID, processed for, payment underscore details amount, payment underscore details currency. Storing payment logs in CloudWatch. Enable CloudWatch logging. In the Lambda function settings, enable CloudWatch logs. Use CloudWatch to monitor and troubleshoot payment processing activities, log events. Integrate logging into your Lambda function. Import logging. Logger equals logging.getLogger logger.set, level logging.info. Def lambda underscore handler event, context. Logger.info processing payment, hash payment processing logic. Logger.info payment processed successfully. Conclusion, key considerations for successful implementation. Building a secure and scalable payment processing system with AWS Serverless architecture involves multiple components working seamlessly together. Key considerations include security. Implement robust authentication and authorization with AWS Cognito. Scalability. Leverage AWS Lambda and DynamoDB for automatic scaling. Monitoring. Use CloudWatch for logging and monitoring to ensure system reliability. Notifications. Implement SNS for real-time payment notifications. By following these podcasts, you can create a secure and efficient payment processing system that meets the needs of your business and customers. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.